Now that we've talked about exponential functions, we're ready to cover logarithmic functions. This chapter focuses primarily on the natural logarithm function, but I think it would be helpful to start out by just reviewing what logarithms are in general. Logarithms are exponents. In other words, logarithms are a way of talking about exponents. For example, consider the statement 4 cubed equals 64. That gives us a description of the number 64 in the equation. It's 4 cubed, 4 to the third power. But how could we describe the number 3 in this equation? Well, 3 is an exponent, so if anyone had asked me, I'd probably call it that. Exponent, and then maybe say it's the exponent of 64. In other words, the exponent you'd need to use to get a 64. Oh, but that's not quite enough information. What exponent would I use to get 64? Well, yeah, 4 cubed is 64, but 8 squared is 64. So am I talking about the exponent 3 or the exponent 2? Well, I have to specify the base. So let's put a little subscript for the base there. And then this would be a way of saying that the exponent you'd put on 4 to get 64 is 3. Now, unfortunately, nobody asked me, and so they're not using the word exponent here. So this is just, Lonnie made this up. It's not what you really say. What they did was they came up with the word logarithm. So where I would have put exp for exponent, they're using the word logarithm. Logarithm really just means exponent. And instead of using the first 3 letters exp, we're going to use the first 3 letters log. So what we really would say here to describe that 3 is we'd say it's the log base 4 of 64. Again, that's read log base 4 of 64. And it means the exponent you would raise 4 to, you would raise base 4 to get 64. And of course, as we said, that number is 3. So maybe I should put is 3. So log base 4 of 64 is 3. Notice that word base applies in both ways of describing this relationship between 4 and 3 and 64. In the exponential statement, 4 cubed equals 64, we say 4 is the base. And that's why in the equivalent statement that's talking about the exponent, in other words, the logarithm, we say 4 is the base. So in other words, the definition of one of these logarithm things, say log base b of a equals x, that's just another way of saying that if you took b and raised it to the x power, the answer you would get is a. So b to the x equals a is another way of saying log base b of a equals x. Let's get a little practice converting back and forth between these two ways of talking about this relationship. So let's convert the exponential equations to corresponding logarithmic equations. So starting with 3 squared equals 9, I want a way of talking about the exponent 2. How could we describe that? Well, it's the exponent, in other words, the log, that you'd put on base 3 to get 9. And some of you in algebra may have learned this kind of like curly thing. 3 squared equals 9 is what 2 equals log base 3 of 9 is. Let's try one more of these. let's take the exponential equation, y equals 7 to the x. How could we write this in terms of logarithms? Well, we could say x is the exponent. In other words, x is the logarithm, because logarithm is really just another word for exponent, that you put on base 7 to get answer y. Let's try converting in the other direction. Let's start with logarithmic equations and convert them to exponential equations. So what's another way of saying that the log base 5 of 25 equals 2? That's saying if I take base 5 and raise it to the exponent or logarithm 2, I will get 25. What about y equals log base 6 of x? That's saying if I take the base 6 and raise it to the thing the logarithm is equal to, remember the logarithm is telling you what the exponent is. So we have 6 is the base. What's the exponent? It's the logarithm. So that y is the logarithm. And what happens if you use that exponent or that logarithm on the base, you get the answer that shows up in the logarithmic equation right after the log in the base. In the next video, we'll look at graphing logarithmic functions. But before you watch that, please go ahead and do the two build your understanding problems here. They're very similar to examples 1 and 2 that we just did. So it's okay if you get them wrong. This is just a check for you to see if you understand and if you have questions you want to ask me. So do that, and I'll go over this with you at the beginning of the next video.